Basically, I wanted us to move to what's called a concept that is called subnetting. But before we do that, it's very important to know what we're going to subnet. So you can't jump to subnetting before we understand the concept of IP addresses and MAC addresses. So that's why I decided to branch here first before we can go to the actual class of IP address subnetting. In every networking, we need to understand what we mean by network addresses. Network addresses, basically, we have IP addresses and MAC addresses. So in this topic, we're going to cover what we mean by IP addresses. Is there anything that I can use to write here? Yes, we are going to cover what's IP addresses. Then we are going to cover, in terms of IP addresses, we have IPv4 and IPv6 addresses. So under IPv4, we're going to understand IPv4 classes. We understand the subnet mask, what we mean by network ID and host ID. Then we're going to look at the differences between IPv4 and IPv6 addresses. Then a very important concept also that is called a MAC address. MAC address, very important. We are going to check what you mean by MAC addresses and the components of a MAC address. Then finally, we're going to see the differences between IP addresses and MAC addresses. So it's very important. And without wasting much time, let's start with the IP address. IP address basically stands for Internet Protocol. So the Internet Protocol, or IP, is just a logical address. It's just a logical address that works at the network layer of our SI model. So basically, it works to enable devices to communicate. So it's very important to note that IP address is a logical address and it works at the network layer of our SI model. I believe these are the simple theory that I sent note earlier. So you can just check the OSI model, the layers of OSI model, and what the protocols that are working on that layer, and the function of each layer. So we see that IP addresses works to enable devices to communicate in the network. And we also there are two types of IP addresses, IPv4 and IPv6. So let's start with IPv4. IPv4, just like we've said that IP address is a logical address, it consists of numbers and is divided into 4 sections or octet separated by dots. That's IPv4 address. Consists of numbers and is divided into 4 sections. The sections are called octets, and these octets are divided by dots. We see that each octet or section contains 8 bits. Each octet or section contains 8 bits, and the entire size of IPv4 address is 32 bits. So each octet, there are 4 octets, each octet 8 bits, so 4 times 8, 32. Then we can have either a public or a private IP address. So this is an example of IP address. We've said that it consists of numbers and is divided into 4 octets separated by dots. So this is the first octet, second octet, third octet, and fourth octet separated by dots. All right. Private, we say that IPv4 address can either be private or public. So we see that a private IP address cannot access the internet. Like what we need, it cannot access the internet. We are going to learn this in the coming classes about network address translation. So the private IP address is just used within the local area network. You are inside network. But when you want to route outside to use internet, you purchase what is called a public IP address. That's why internet, whenever you want to use internet, you have to pay. But you can just even at home, you can just configure two computers with the same IP address and try to ping the other computer. It's reachable. It's free. So we see that private IP address cannot access the internet. But a public IP address can access the internet. Now we have to pay. That's why sometimes you buy data bundles. Whenever you buy data bundles, what you're being given is just a public IP address for a fixed period of time. But for a private IP address, it's free. You don't need to pay anything. By default, it is in the computer. That's a private IP address. But for a public IP address, you get from ISP, you purchase it. Whenever you buy a data bundle, just know what you bought is just a public IP address to enable you access internet. Then how do we verify a private IP address? You go to CMD and write this one, ipconfig/all. But how do you verify a public IP address? This was for private, and now this is for public. You just go to Google and type what's my IP. Okay, we're going to demonstrate that right now. So before we go to the actual demonstration, this is an example of a private IP address, and this is an example of a public IP address. So for example, you can see this is an inside LAN. An inside LAN will use a private IP address. These are private IP address, and for this LAN to reach internet, then they must purchase a public IP address. So let's go to verify my addresses. Let's go and verify my I'll go here. The first method we want to verify my private IP address. I just go to CMD and I just write ipconfig. So whenever I'm currently using Wi-Fi, whenever I write ipconfig, you will see that my IP address is this one. I have the subnet mask and the default gateway, it's here. So that's my private IP address. That is from my router, the router that I'm using, the router that is providing this wireless connection. So this IP address enables me to only reach the router. Now, the IP address that will enable me to reach from the router to the internet is called public IP address. So that you just go to Google. Just a minute. Just go to Google and just type what is my IP address. So this is my public IP address that I'm currently using.
Let me try it.
Yeah. What is my IP address? So you can see your public IP address is this one. But for a private IP address, it's in the computer. Not permanently. It's provided and attached to the computer by the router or any other networking device that is providing the
public. So for the computer, like for me, it shows me like a very long number, 2603.6000. So a lot of,
Sorry?
So my IP address is, what's my IP address? It shows me something like a very, very big number.
I think in USA, you people have started using what's called IPv6 address.
Yeah, it's like IPv6.
Yeah. So just a minute. Let me just is it kind of example of IPv6? You know, in Kenya we're still using IPv4. So is it something like this?
Actually, yeah, like that.
Yeah. So you people have started using IPv6. You people have started using IPv6 for public IP address, but for us, we're still, you know, IPv6 is a new technology, and it will take us time to move there. All right. So I'll go forward. So you know, in the concept of IPv4 addresses, we have what's called classes. Just a minute. Like that. Okay. So we have what's called classes. In IPv4 addresses, we have 5 classes. We have class A, B, C, D, and E. And for each class, there is a range. And for each class, there are some classes that we can use, and there are some classes that we can't use. So, for example, we start from class A. IP address range starts from 1.0.0 to 126.255.255.255. For class B, IP addresses range start from 128.0.0 to 191.255.255.255. Class C, 192.00 to 223.255.255. Then class D, it starts from 224.00 to 239.255.255.255. Then finally, class E starts from 240.00 to 255.255.5 to this one finally. And then we have comments. For class A, there is a range that was not specified under the normal IPv4 range, which is 127.00 to 127.255.255. So these IP addresses is normally used for localhost, for mainly for loopback IP address, reserved for loopback IP address. A loopback IP address is that kind of IP address that is used to test self-communication. What do you mean by self-communication? That means, are you able to communicate? Loopback in I know it's a little bit confusing. A loopback IP address is that kind of IP address that is used to test self-communication. Whenever you can talk, are you able to talk? Can you communicate? How do we test that? We use loopback IP address. It's used to test TCP IP suite. When what I mean is that, sorry, it's used to test whether TCP IP suite is working in the networking devices. If that device is able to communicate, self-communication, are you able to talk? Are you able to communicate outside? Okay. Then for class B, we don't have any comment. Class C, we don't have any comment. And from class A to C, they're the only classes that you can use. You can only use from class A to class C. We can only use from class A to class C to assign devices. Now from class D to class E, they have different purposes. For example, class D is only used for multicasting. We will see a sample when we are going to configure SPF. And for class E, it's now reserved for future development and research. It's not even used, it's only reserved for research and the future development. But you have to know that we only use from class A to class C. We don't use class D or class E. So that's why you can see all of these are blank. Now let's shift our focus here from class A to class C. Now we go to the concept that's called network numbers of octets and host number of octets. So a class C address, we have the first octet as the network ID and the last three octets as the host IDs. Network ID basically means that the part of IP address that is used as the network address, but the host ID is the part of IP address that can be used to assign hosts devices. So with this, we see that the total number of network from a class A IP address can be 128, while the total number of hosts from a class A address can be this one. And that's why the subnet mask of a class A address always start from 255. Now for host, these are now 00.0.0. So this is the network address. These are the host address. That's why you see 3 H here and 1 N. Now let's go to class B. Class B address, we have 2 network portion and 2 host portion. So the subnet mask should be 255 dot 255.0.0. So the first 255 are the network portion and the last 20 are the host portion. All right. Now let's go to and the total number of networks that we can derive from a class B address is this one, and total number of hosts can be this one. Finally, for class C address, we have 3 network portion. The first 3 octets or the portion or the section are for network, but the last octet is for hosts. So the subnet mask should be 255 dot 255 dot 255 sorry, it's hard to write here, .0. So the first 3 octets are for network, and the last one octet is for host. And we can see in class C address we can derive this number of networks and the total number of hosts. All right, so we move forward. It's very, very important to master the classes in IPv4 addresses. Very important. You have to know them. Yeah. So after doing that, it's so important to understand the differences between IPv4 and IPv6 addresses, IP addresses. So for IPv4, it was deployed some years back, 1981, but for IPv6, just previously in 1998. For IPv4, the length of IPv4 is 32-bit. That's why you can see only there are 4 octets. But for the length of IPv6 is 128 bits. That's a lot. And for IPv6 there are 16 octets, I believe. Yeah, 16 octets. That's why you could see a very long number when you typed show my IP address. Then the number of IPv4 address currently is only 4.3 billion, which is the number of human beings is much higher of the number of IPv4 addresses. And that's why IPv6 came up to solve that problem. You can see the number of addresses are this one. A lot of this one is also almost under zillion, 7.9 under zillion. No human being at no point will human being reach under zillion number. Okay, and then IPv4 address, you can see, must be reused and masked. So you know, for example, the same IP address I'm using right now, someone is using it somewhere else, because they can be reused and masked. But for IPv6, every device can have a unique address, because there's a lot of IPv6 addresses available. There's no need to reuse any. Also, we see that IPv4 address is a numbers with a dotted decimal notation. For example, this one. But for IPv6, it's an alphanumeric hexadecimal notation. So it consists of numbers and letters with a colon, with the colon dividing the octets. And finally, for IPv6 DCP, it supports both DCP and manual configuration. But for IPv6, this is for IPv4. Now for IPv6, it can support auto configuration. A device can just auto configure itself with the IPv6 address instead of needing a DCP server. So all of those will look later in the classes. And finally, in the class, we need to understand what we mean by media access control address, which is mostly known as MAC address. So a MAC address is just a physical or hardware address, and is used to enable communication in the network at the layer 2 or data link layer. So we see that IP address was a logical address that works at a network layer to enable communication. But now we see that also MAC address is a physical address or a hardware address here, and it works at data link layer or layer 2 to enable communication. The essence of these network addresses, they are used to enable communication. So the difference comes whether they have either physical or logical addresses and at which layer they are working. For IP address, we see that they were working at the network layer. MAC address, data link layer. Then IP addresses are logical addresses. You know, you can configure your own. But for a MAC address, is a physical. It's burnt. It's how can I say it? It comes pre-configured and you can not change it. It's just configured and burnt in the motherboard. You can't change it. Another thing, every device has a unique MAC address. Very important. Well, previously we could see that we can reuse IPv4 address. Two or more devices can have same IPv4 address, maybe in different networks. But every device has a unique MAC address. You cannot find two devices with the same MAC address. Why? Because MAC address is burnt or comes pre-configured from the company, so you cannot change it. And the company knows very well the range that they should use. It's permanent and cannot be changed. Very important. It's made up of 6 octets and separated by colon, dash, or dots. We could see that IP address is made up of 4 octets and separated by dots. But now for our MAC address is made up of 6 octets and can be separated by colon, dash, or dots. And we see that a MAC address is comprised of two parts. The first part is a vendor part, and the second part is a host assignment part. So what does that mean? For example, this is a MAC address here. We see that the first part should consist of a vendor. For example, HP is manufacturing their laptops, and they want to give laptops MAC addresses. Now, the first three parts should be the format or kind of HP proprietary format of giving MAC addresses. So the first part, this which is known as organizationally unique identifier, the first three. So this one should be the same for all HP devices. For example, if this was the format of an HP MAC address, then this part should be similar to all HP devices because it's the organizationally unique identifier. Whenever you see this, any MAC address that start with this one, you just say that this is an HP device. Okay, so all the MAC address bears the parent company identifier. So any host device will take this part. So this is the part that will change. It's called network interface controller. It will change depending on the devices. But the first part should never change because it's used to identify the company. Now, the second part is used to identify the device. It can change the way you like it, the way the company likes it, because it's the company that manufactures this market that allocates this market as to each device. All right. Finally, let's understand the differences between IP and MAC addresses. So, MAC address is a 6-byte hexadecimal address, but we see that IP is a 4-byte for IPv4, then 6-byte for IPv6 address. You know, we have two IP addresses, IPv4 and IPv6. So IPv4 is 4-byte, and IPv6 is 6-byte. Then is it really? No. IPv6 cannot be 6-byte. 1 byte is equal to 8 bits. So 1 byte is equal to 8 bits, and IPv6 is 128 bits. So 128 divided by 8 is around 16. So here should be 16 byte. Sorry. All right. Now, point number 2, we see that in MAC address, ARP, which is Address Resolution Protocol, is used to get MAC address of the devices. But in IP address, we see that it's a reverse address resolution protocol is used to get IP address. Point number 3, we see that network interface card manufacturer provides the MAC address, meaning it's permanent and you cannot change it. But for the IP address, anyone can assign it, be it a network administrator or internet service provider provides the IP address. MAC address is a physical address of the computer, while IP address is a logical address of the computer. We see that MAC address operates in the data link layer of a SIM model, very important, while IP address operates at a network layer of a SIM model. But number 6, we see that MAC address helps in simply identifying the device. But IP address just identify the connection of the device to the network. something permanent on you is used to identify you, but something like, let's say, phone number is just like IP address. You can change it anytime. Phone number will only identify that you are connected to which telecom network. For example, in US, I don't know which telecom network you're using. In Kenya, we're using what's called Safaricom. So phone number is just like IP address, and it's used to identify the connection of the device on the network. So my phone number just tells me that I'm connected to Safaricom ISP, but my MAC address is a permanent thing. It's used to identify yourself permanently. Alright. MAC address of a computer cannot be changed with the time, and environment to it is fixed. As I have said, the manufacturer ban it. For example, they program it on the network interface card and ban it on the motherboard. Now you cannot change it, but IP address you can change as much as you want. Finally, MAC address cannot be found by third party. IP address can be found by third party. Yeah. So there are only manufacturers of MAC addresses, designated one. So for IP address, anyone can just input any IP address that they like. All right.